Okay, Assalamualaikum. So we meet again at tutorial chapter 8. So today we will do question number 3 and 4. A heavy uniform plank at length L, so this is length L, supported by two force F1 and F2. So we have F1 and F2 here. At distance L over 4 and L over 8 from its end as shown in figure 8.1. Find the ratio of F2 and F1. So they ask you to find ratio here. Okay, so because the word uniform here, it means is it equilibrium lah ataupun dia berada dalam keadaan constant, dalam keadaan balance. Equilibrium means balance, means uniform. Okay, so what the first thing we need to do, we need to draw free body diagram lah. So this is my plank. So this is my width. And then we have F1. So let's say my F1 going up lah sebab dia going up, right? And then we have F2. Okay, this is total here is L. So they give you L. So if you remember back, the first thing we need to draw is sketch free body diagram. So this is our main character lah. Kita punya main character tadi adalah plank tu lah. Okay. And then number 2, we need to determine the pivot. So my pivot is here. I put my pivot is here. At the center here. So this is my pivot. So we need to find the distance lah between pivot and here. Okay, since they give you here is L over 4. So weight, usually the length here adalah L over 2 lah divided by length over 2. L over 2. Okay, so this is L over 4. So what we can say here is the length here adalah L over 2. L over 2 minus L over 4. So L we can factorize. So 1 over 2 minus 1 over 4. So you can get 1 over 4 back. So your answer will become L over 4 lah. So this is L over 4. Okay, so we need to find this L pula. Okay, so here they give you adalah L over 8. So meaning L over 2 minus L over 8 because this is also half. So equals to L, we can factorize 1 over 2 minus 1 over 8. So you will get the answer is, okay, so if I minus this, I will get 3 over 8. So here we get L equals to 3 over 8. So this is 3L over 8. So we already have the length lah. So this is the length that we will use lah. Okay, so because the word equilibrium, balance, so what is the law for the condition? They have two conditions for the equilibrium, which is submission F must be equal to 0 or submission torque equals to 0. So we will use the submission torque equals to 0. So submission torque equals to 0. This is your pivot. So how many force we have here? So we have 1, 2, 3. So the torque belongs to the weight will become 0 because dia duduk kat pivot. So dia akan jadi 0 lah. So my submission torque, actually we have 3 lah. So torque F1 plus torque weight plus torque F2. Okay. Ini kalau the best way sebenarnya adalah buat table. So katakanlah kita buat table yang ini akan sambungan kosong lah ini. Okay, kalau saya buat table, kalau you tengok table saya, maksudnya dia akan jadi macam ni lah. Okay, ini adalah saya punya forces. Ini X, ini Y, ini saya punya torque lah. So saya ada F1, F2, W. Okay, so ini adalah submission F. Kosong, kosong, kosong. Submission torque pun mesti kosong sebab perkataan equilibrium. So F1 saja tak ada kat pasti X, semua kosong, kosong, kosong lah. So F1 saya positif sebab dia ke atas, F2 pun positif, dia ke bawah, weight pula negatif W. Okay, saya tak boleh guna ni sebab there are too many unknown, saya tak tahu. F1, F2, okay, maybe dia nak cari, okay, tapi I don't know W because dia tak mention dalam inward in term, so cannot lah. So I cannot use these two lah, tak boleh. Sebab dia menemui jalan mati lah. So that's why I have used torque. Okay, macam mana nak buat torque? Okay, W. Ingat tak tadi dia duduk atas pivot. So the torque here is 0 lah. What is the formula torque? Torque sama dengan FD lah. Dalam kes ni FD sebab dia semua perpendicular. Kalau you tengok ni, dia adalah perpendicular lah. Okay, so saya akan letak pembaris. So this is my pivot. So F1 bila I tolak, dia akan bentuk macam ni. Dia akan buat bentuk clockwise lah. The angle will be clockwise. So that's why kita akan letak negative F1 D lah. D1. So this is D1. D1. Okay, F2 pula saya letak ni, pembaris saya ketuk-ketuk sini. Okay, yang ni saya tolak, dia akan jadi anti-clockwise. So dia positif lah. F2 D2. So where is my D2? Here. This is my D2. So saya akan dapat macam ni lah. Okay, so saya akan menggunakan the one that I get here to make my ratio lah. I will use this. Okay, so kita akan gunakan, so saya pada yang ni. So kita buat yang ni. Alright. So what we did is just that we substitute je lah. Okay, so we get submission torque equals to negative F1 D1 plus F2 D2 equals to 0. Okay, so F1 D1 we will get L over 4 plus F2 D2 is 3L over 8. Okay, equals to 0. So negative here, we can bring here, you got positive. So you get F2 3L over 8 equals to F1 L over 4 lah. So LL we can cancel. So yang lain bawa ke sana because we want to find a ratio. So we make it F2 over F1 lah sebagai subject. So you akan dapat 2 over 3. So ini je lah jawapan dia. So yang lain tu you bawa lah. So you bawa 8 sini, sini bawa sini. Alright. Alright, question number 4. A 1 meter road of mass 2 kg. So this is the length 1 meter road 2 kg pivoted at P. So they already mentioned the word pivot. So kalau dia dah mention you pivot, you cannot buat tempat lain lah. So you have to choose this. You have to follow lah. This is your pivot lah. So this, maknanya anything that forces acted along this line akan jadi 0 lah. Torque lah. Torque not force. Anything torque yang akan line this akan jadi 0. Okay, a load of 6 kg is suspended at the end one end. So this is your 6 kg. And one end, another load mass M. M lah, unknown is suspended at Q. Okay, E is equilibrium. Okay, what do you understand about equilibrium? So submission F total equals to 0 and submission torque equals to 0. Determine the value of M. Okay, so what we need to do, the best way adalah draw free body diagram. So this is my main character. Ini main character saya lah. Sebab apa? Kalau in chapter 4 and chapter 5, 6, 7, do you have to put dot that is represent object. But now this is your object. Your object you adalah bentuk yang mengalami rotational lah. Okay, so I have weight 6 kg. I have weight M. I have weight of the beam. This is road. Okay, weight of the road. Because road also have its own weight ya. And then this one, dia adalah tempat yang dia memegang benda tu. So we have normal. So we have normal. Sebab dia sentuh with the surface. So this is your point P. Okay. So we have 1, 2, 3, 4. This is the only 4 force lah. So this is Q, dia bagi Q. This one is 30 cm. So this one is 20 cm. Okay, so nanti kita akan carilah dia punya jarak lah for the hole. Because the hole here adalah 1 meter. Okay, 1 meter. So weight adalah sentiasa in the middle. So this one will become half lah. So this one will become, because 20 cm. So yang ni adalah 15 cm lah. Ini 50 cm. So ini 50 cm lah. Sebab jarak dia separuh-separuh kan. Okay. So 50 minus 20. So here you get 30 cm. Okay, yang ini pula weight ni, because this 30 cm, so 1 meter, tapi ni separuh, so this one akan jadi 15 minus 30, this one is 20 cm. So the length that we will use is 20 cm, 30 cm, and 20 cm. This is the only that we will use. Other than that, kita tak akan guna lah. Okay, dah settle free body diagram, buat table. Okay, buat table lah. Macam biasa kita buat table. Cuma kali ni we have another one lah, torque. Iaitu yang ni forces X, Y, torque. Torque saya akan buat FD equals to FR sin theta. Because kalau dia bukan 90 degree, kita akan guna FR sin theta. So how many forces we have here? So kita letaklah, kita ada W, N, W root. Ni W6 kg W6 kg, W root and WM. Okay, so lepas tu kita akan buat submission lah. So ini submission F00, submission torque sini akan 0 lah. Kenapa 0? Again, because the word equilibrium. So dia equilibrium, so dia akan jadi 0 lah. Okay, X, nothing, 0, 0, 0. Tak ada langsung dekat X. We don't have any forces acted on X. Okay, on the Y. So what Y? This will become negative lah. Negative W6 kg. This one positive N. Negative W root. Negative WM. Okay, this is your pivot. Where is my pivot? Pivot is here. They mention the word P. So kalau boleh letak dekat sini, yang you letak ni top, atas dia tulis at pivot P. So we know that any forces acted on yang duduk in the same line with the pivot will become the top will become zero lah. So I mean our case here weight root lah. Weight n, sorry n. N yang duduk atas pivot. Kalau you tengok n ni dia duduk atas pivot. So here akan jadi zero lah. So n dia punya submission top dia akan jadi zero. Okay, so kita buat dengan W6 kg first. Okay, bayangkan saya letak pembaris. So ketuk-ketuk sini, so ini akan berputar macam ni lah. So dia akan berputar anti-clockwise, so dia positif. So dia jadi positif W. So the distance here is 20 lah. So 20 tukar lah ya. So 20, so you get 20 times 10 power of negative 2. Sebab dia perpendicular. Dia perpendicular dengan pivot. Nampak ni, perpendicular. Okay, and 0. Okay, W root. So, where's my W root? Here. Okay, so I letak ni and then pembaris, I ketuk-ketuk. So, dia akan berpusing macam ni. Akan jadi clockwise. So, dia jadi negatif lah. Negatif W root and the distance is 30 cm lah. 30 times 10 negative 2. Change everything as I unit. Dan dia pun 90 degree. Kalau you tengok ni 90 degree. Okay, WM. So, this WM. So, dia pun akan berputar secara clockwise. So, it's become negative WM. So the distance here is 20 lah. 20 times 10 negative 2. Okay. If you look at here, there are one mistake that we did. Okay. So 20 cm here, if you look at back, 20 cm is from the weight of root until the weight of the M here. My pivot is here. It's not at the weight of root. So I have to panjangkan lah here. So I was not taking the 20 here. So I have to plus another 30. So here it will become the 50. So ini akan jadi 50 lah, 50. Okay. So dah settle yang ini. Sentiasa check, always check. Yes, kita akan make mistake lah. Sentiasa check. Okay, this one yes 20. This one is 30. Yes, this 50. Sebab ni 20 plus 30. Sebab tadi 20 I ambil anjalah sampai kat root. Ya. Sebab 50 tolak 30, 20, 20 sampai sini. Kita nak sampai habis ni. Okay, so buatlah submission top sama dengan W. W tadi 6. Rasanya 6, 9.81. 20 times 10 power of negative 2 minus W root. Okay, berapa dia bagi tadi? 2 kg. So 2, 9.81. So 30 times 10 negative 2. W minus lagi WM. M we don't know mass, but we know 9.81 lah because they ask mass not weight. So weight equals to mg ingat balik tu. So 50 times 10 power of negative 2. Okay, this one all here is equals to apa? Equals to 0 lah. Because here is your top equal to 0. So this one and this one you can calculate and then bawa ni lah. So yang itu guna calculator ya. So you will get your answer for M adalah jawapannya adalah you will get is 1.2 kg. So this is the answer. So the trick one is the mass here lah. Tadi kita tersilap yang dekat sini. So be careful dekat here. Sebab yang ni dia panjang from here to here. Alright, question number 4B. Okay, what they ask you, a 10 kg. So this is the mass of the uniform bin. Again, word uniform meaning is dalam bentuk apa? Equilibrium lah. So 2 meter. So this is the length 2 meter. Panjang dia adalah 2 meter long. Pivoted at the center. They already mention you the where is your pivot lah at the center. So jangan ubah. If they don't mention you pivot, then choose the one that have most forces. Kalau they mention, you cannot change the pivot. Okay, 20 Newton perpendicular forces exerted on 0.5. So they give you here the force, the applying force at the center, from the center of the bin. If the bin is equilibrium, the word equilibrium again. Okay, find F. Okay, so they ask you to find F. Okay, so what we need to, this one lah, our main character here, they ask you to find F here. Okay, I draw my free body diagram. So macam mana bentuk free body diagram saya? This is my bin. Bin saya cantik lah pula. Okay, kita buat bin. Okay. Alright, so I have force, the one that I want to find. I have weight of the bin. So this is my pivot. So pivot lah, kita akan letak pivot here. Okay, so selalunya pivot ni you letak point lah. So saya letak P lah, point P here. So ni my pivot kat point P. And then I have another one which is 20 Newton lah. So how many forces acted? Ada 1, 2, 3 and jarak here adalah 0.5. Okay, so kita kena cari jarak because the jarak they give you to you adalah tadi adalah 0.5 tu from the center. Okay, this one we will use because this is my pivot. So this one, the jarak here we want to find lah. Okay, since dia bagi tahu yang ini adalah duduk kat ujung and this one is your center. So 2 meter ni divide by 2 lah. So this is 1 meter lah. So here is 1 meter. Okay, you buat table macam biasa, buat table. Ini adalah forces X, Y, torque. Torque equals to FD or FR sin theta. Okay. Dan the best way letak atas ni at pivot P. So you tahulah pivot you dekat sini lah. This is your pivot P lah ya. Okay, so how many forces we have? 20 Newton, weight of the beam and F. Okay. Then dia bagi tahu mention the word equilibrium. So submission F saya akan 0, 0. Submission torque saya akan equals to 0 lah. So this is the thing lah we need to know. Okay, so X. Ini kena be careful lah sebab yang ni macam dah sengit-sengit ni kalau you tengok ni. Okay, so kalau kita tengok dekat sini, W bin tak ada masalah. Dia hanyalah negatif W bin. So F pun also tak ada masalah. Negatif F, dia ke bawah. Okay. So tapi kalau kita tengok pula kepada X ni, kalau you tengok X you ni, dia bukan duduk atas X. Dia macam sengit. So dia akan ada angle. So dia ada angle. Problem lah tu. So kita akan biar je lah. Kita buat dia adalah 20 cos theta. Sorry. And then dia ke bawah kan. So dia negatif 20 sin theta unknown. Tak apa. Biar je buat unknown. Okay. So kita buat yang ini pula. Okay. So yang ini siapa duduk kat pivot. So this is W bin. So my torque here akan jadi 0. So anything that forces acted on the pivot, the torque here will become 0 lah. Okay, tengok 20 Newton. Okay, 20 Newton, this is your pivot. You letak, ambil pembaris, you paku-pakukan dia. So, dia akan menolak ni. So, dia akan jadi anti-clockwise. So, it's become positive lah. Positive 20 and the distance is given 0.5. Sebab dia perpendicular. You tengok ni perpendicular. Okay, F pula. F ni, you letak pembaris, you ketuk-ketuk. So, dia akan adalah clockwise. So, it's become negative lah. F and the jarak here is 1 meter lah. So, jarak dia adalah 1 meter. Tapi cuba you tengok balik. Walaupun jarak dia 1 meter, but we have angle. The angle here is not 90 degree. So, it cannot be D. So, kita akan guna yang ini. FR sin theta. Yes, my R yang ini bukan D lah. Yang ini akan jadi R lah. This is R lah. So, dia akan jadi R sin. Okay, how do you want to find the angle? So, look at here. They give you angle here 50. So, sin 50. So, kita akan guna yang ini lah. Okay, why don't I use this? Because this one they ask you to find F, right? Okay, you can use this, but you need to find the angle here, theta here. So, kita guna yang ni lah. Kita fokus dekat torque ni lah. So, submission torque equals to 20, 0.5 minus F1 sin 50 equals to 0. Okay. So, dari sini, this is the only the F that we don't know lah. So, you calculate lah. So, you will get the F is 13.05 Newton. So, this is the answer.